Good afternoon, everybody. My name's Alex Leith, and over here is Cami Raju, and we're here to talk to you about Digital Earth Pacific. Digital Earth Pacific is hosted by the Pacific Community, or SPC, which is an organisation that represents 27 member countries and territories, and does a range of things. Cami might be able to talk about this a little bit further when we transition over. And I'm very privileged to work on that from my company, and I spend about half my time working on Digital Earth Pacific. My expertise is around cloud-native geospatial, and I'm very privileged to be able to work with lots and lots of data, usually Landsat and Sentinel-2, to teach people how to do that as well. So we've all seen these kind of glossy, shiny reports that talk about the economic value of Earth observation. And there's some big numbers in there by people, reports by people like the World Economic Forum, which for some reason everybody trusts them when they say huge numbers like billions of dollars of value. But I think that we all know sort of intuitively that with the advent of the accessibility of large amounts of Earth observation data, there are huge opportunities in lots of different industries for people to be able to use the data to make better decisions, or to understand the world, or to sometimes even predict the impacts of climate change. And so for a long time there's been people in the Pacific talking about how important Earth observation is for the Pacific. There's been like half a dozen reports over the years talking about priorities and what needs to happen and focus areas and all kinds of things. But finally, just a couple of years ago, there was enough funding and enough political support to start a program called Digital Earth Pacific, which is following on from Digital Earth Australia, which has been around for maybe even 20 years, 10 years probably, and Digital Earth Africa, which has been around for maybe about 5 years. And so there's been a needs assessment report. This was written during COVID, which made it difficult to go out into the countries and talk to all of the countries. But there were online forums sorted out with a range of countries, listing out priorities, things like land cover, coastlines, and there's a Digital Earth Australia product that we'll show later, which has been adapted to the Pacific Island countries to look at where the coastlines are. Agricultural, hazard mapping, digital elevation models, all kinds of things, very useful, and great applications of Earth observation data. So we have a program, we've set up all the governance stuff, we have meetings with people on Zoom from all over the place, from representatives from NOAA, from Geoscience Australia, and across all the Pacific Island countries and territories. That's all very important. The more important and more fun stuff for us is all the digital stuff. So we're building infrastructure. We've got Kubernetes, and we've got a Jupyter environment to do data science in. We use open data, so we consume Landsat, Sentinel-2, like I said before, Creative Commons data, and we produce data as well. And so that data is then made accessible directly, stack catalogs, stack APIs, all of this open infrastructure, common specifications or standards, as you want to call them. So last year I worked on this strategy, a technical strategy, and I'm kind of proud to break it down into 3 kind of keywords: empowering more people from the Pacific to access and analyse data, simplifying that access to Earth and ocean observation data, and then also to deliver new products specific to the needs of the Pacific. So that's our tongue twister, so you can give that a go if you want. Specific to the Pacific. Statistics, huh? Yeah, no? Yeah. But I kind of like the breakdown, you know. Like, we want to empower people. We want to teach. We can help people, not just do it for them, but help them to learn how to do it the same way that we do it. But also put together some exemplar products. So a broad overview, we're in phase 1, where we're setting the foundations, learning how to do what we want to do, starting to go out and talk to people. As of next year, we really want to do a whole bunch more capacity development, engagement, get more people working on it. That's people within SPC, but in other organisations across the Pacific. And then more and more deliver operational data products. So that means we're not delivering something once and then letting it drift out of date. But each year, as we get to the end of the year, we do the annual data products and keep it rolling out as an operational infrastructure. Now, I talked about this the other day when I did the Cloud Native Geospatial workshop. And for folks that aren't EO or Earth observation kind of people, there's some really big sort of landmark capabilities listed up here. And so I started working in the Digital Earth Australia program about 6 years ago. And at that time, the USGS for Landsat, well, no, let's step back a little bit. So in the past, Geoscience Australia started the Digital Earth Australia program, and at that time, the Landsat data, which has been captured all the way back since about 1980, the early 1980s, it was stored but on archival tapes. So if you wanted one, you need to go and dig it out of the cellar, out of the dungeon, and find the machine that reads it and get the data off it. And so there was a project in Geoscience Australia called Unlocking the Landsat Archive, and so they got those tapes, put them onto spinning discs in a data center, shipped the data off to the USGS in America, and eventually the Landsat data, all of it is actually accessible. Once you've got the Landsat data, the photos, you need to process it to analysis-ready data. So that means processing it to level 1, which does the geometric corrections, and then level 2, which is radiometric corrections. That means you can compare a scene captured in January to one in June, and over time, the differences in the pixel really showed the differences on the ground and not the differences in the atmosphere. So we're talking about having Landsat data available, analysis-ready data defined and processed. The USGS produced a processing of their entire collection, so that's 40 years of data across the entire world. That's now called their Collection 2 product, which is available everywhere. Sentinel-2, ESA only finished back processing their Collection 0. Matt, when did they finish doing that? It was like 2022 on its own, wasn't it? That they finally got all that done. And then having it accessible in the cloud. You know, USGS with their Collection 2 published all the data onto S3, so you can access all of it now. Matt was instrumental in actually getting Sentinel-2 data out of ESA and published online as cloud-optimized geotiffs, which makes it much easier to access than it used to be. And these days, we've got a common specification for the spatiotemporal asset catalog metadata, STAC, for all of these products. So you've got global Landsat, global Sentinel-2, a range of other products like Sentinel-1. And just a few years ago, this stuff was like a dream. It was a fantasy. So it's hard to overstate how important and how impactful that is. So it makes the work of Digital Earth Pacific a lot easier, really. Digital Earth Australia needed to unlock that data to get it and make it accessible. Digital Earth Africa had to take a copy of it, actually wait for it to be produced as well, and shipped it to Africa. Digital Earth Pacific, we actually run all of our stuff right next to the data. It's all there, and so we can just start getting productive, and it's a big deal. So when am I handing over to you? Here? I'll pass over to Cami. She's going to talk about some of the products that we've been producing.
Hi. Okay, so when I say we developed things, it wasn't me. It was Alex, my team leader Sachin, and another genius named Jesse. I just take some of the credit for it. So Digital Earth Pacific, when I explained to my mom what I do, it's basically that there's a bunch of satellite imagery. Somebody else takes the imagery and processes it and creates regional products. We also have some specific country products, but let's talk about the regional products today. And then we also teach people how to use it so that they can make their own products. So for Digital Earth Pacific, we have 3 regional products that we launched last year. The first one is Pacific Coastline Change. So hands up if you've been to the Pacific, anywhere in the Pacific. So you realize how they're tiny islands, right? And you wouldn't think much of it in terms of how much of the coastline it is compared to the globe. But interestingly enough, it's about 10% of the global coastlines. And we have 22 years of data for Pacific coastlines, which means we can analyze coastal rates of change over time and see how the coastlines have moved, which is helpful when we try to tell people that the Pacific is drowning. That's not something we like to say, because we want to say that we're small people, but we're small people, we have big challenges, but we're not completely drowning yet. We also have 7 years of mangrove data, which is helpful because it illustrates loss and recovery, which is important because the Pacific is considered like big in terms of blue carbon and such. We also have 10 years of water observations from space, which is helpful to detect where there was water or where there has been water, and we can see where there might not be water in the future. For example, if it's because of a drought or if it's because of saltwater intrusion. So this is what the Pacific coastlines looks like, and as you can see, this is an example from Solomon Islands. So the lines on the outside, the darker lines, were kind of what the original coastline looked like in 1998, and since then it has moved inward. So as you can see here, the darker ones, it used to be one big island before, but over time it's become two little islands. So this is important when we're trying to explain like how climate change changes our area, our country. I feel like I'm missing some points, and Alex will yell at me later about it, but it's okay. This is so once somebody else created the product, they've been trying to improve it over time. Initially, they were like noisy coastlines. There were multiple lines, and we couldn't really tell where like the coastline used to be and how it's changed. But we've done some analysis, and this is a better product. Initially, there was only the coastline change over time. So as you can see, like the lines were moving inward. But that wasn't very helpful when we were trying to say, like, this is what we need to change specifically. So we have rates of change, and the blue dots kind of mean that there's growth, and the red ones mean there's erosion. So if you can see here, there's like a village here and a village here, which means it's easier to say that like we need to do some adaptation here rather than here, right? So resource mobility becomes easier. This is what our water observations from space looks like. We have a slider which shows you changes over time, whether there was water available or water present over time on any specific area. I have a good example to show you, if I can play the video. Okay, so this is Tuvalu. And whatever you see in the blue is water coming inland, and the orange is where it's been flooded due to king tides. As you can see, it floods almost the entire country, which means they don't have clean drinking water. Their houses are flooded. They don't have good vegetation to eat because of saltwater intrusion and things like that. Okay. We also have a product for mangrove health, and you can see how the mangrove changes over time. Can you see it? A little bit, okay. So in this example, the animation kind of illustrates the impact of Cyclone Winston and the recovery process in Fiji, and how like the mangroves have changed in that period between 2016 to now. So the mangrove extent data starts from 2017, and I've forgotten everything I wanted to say in this slide. But essentially, in 2017, this is what the mangrove looked like, and in 2023, this is what it looks like now. So 2016 is when we had Winston, and it wiped out a bunch of the mangroves. But since then, we've had some recovery. We've also done some analysis on canopy classification. So basically, it means that we're trying to see whether these mangroves are open or closed, whether like how much crown cover there is. So we're essentially trying to see like how the mangroves are growing and whether it's growing. We also have a few in-country products, specifically targeted to Tonga, Cook Islands, and such. But these three products that I just spoke about are regional, so you can find all these things over everywhere in the Pacific. So that's like 27 to 30 Pacific Island countries and territories. We also strongly believe that whatever we do, we want to teach, or we want to enable the people of the Pacific to do as well. So we have an outreach strategy that That essentially means we want to increase awareness of understanding for DEP. We also want to foster engagement with the stakeholders. We don't want to just make products that we want to make. We want to make products that they need and they want for the development of their country. We also want to promote data access and capacity development in their own country so they can do the analysis without having to need us all the time to do it. And we want to position DEP as a thought leader, which basically means we want to help people use DEP to make disaster decisions. We've done a few in-country workshops between 2023 and now, approximately across 6 countries, and we did land cover change analysis, we did coastal classification, we took our bunch of training groups out to do data collection and to get them to do their own land cover classification models. And this is kind of what it looked like. For most of the countries, they don't have capacity or resources to go out and do this themselves. They haven't had an updated land cover classification model in 15 to 20 years. So we've done one for Tonga now, we've done for Cook Islands, we've helped do one for Palau, RMI, and Tuvalu.
Not just done it, we've taught them how to do it as well, and given them a platform to do it on.
Exactly. So just this year, we've trained about 71 participants across 6 countries in how to do these things. As part of Digital Earth Pacific, we also have an analytical hub, which has a bunch of notebooks you can follow along and do your own analysis with. And Alex will talk about all the other developments we were thinking of doing.
Thank you, Cami. So we have a few products and priorities that we're working on. One is satellite-derived bathymetry, which I'm told is really, really hard. So we've got a kind of naive approach here. There's a whole bunch of bathymetry captured over a whole bunch of countries across the Pacific. And it's an exercise in itself to clean and organize the data. One fun example was that depth was sometimes negative and sometimes positive. And so you've got to invert some of them and hope you're inverting the right ones. But we've got some interim outputs. I can't remember where this is. Is that Samoa somewhere? Can you tell? RMI. It's the Marshall Islands. But yeah, so this is getting Sentinel-2 data and using all the bands and putting that into a random forest regression model and coming out with something which looks reasonable in terms of elevation. So we're working on this across the Pacific. One of the products I'm working on, which is a fundamental product to further work, is the geometric median and median absolute deviations, which is a very long word, but really it's like a robust median and then variances from the median. So you get the red, green, blue, near infrared across a year. So it's an annual summary. So you get all of the observations, add them all together into a big mix, make a stew, get a robust median, and then the measures of variance help you get some extra statistics about change across the year in different ways. So this is a really good product for being input into land use, land cover, because a lot of the areas in the Pacific have clouds a lot of the time. And so rather than working on a single image, we're working on a nice, clean, data robust, cloud-free image. And one of the examples of a downstream product is this mineral resource extraction process that we did in Fiji. And so here, Gilberto was talking about using small amounts of high quality data. And so we really did that because what we are looking to identify is these areas where there's illegal gravel extraction alongside the river. And so you can sort of see that in the imagery, but we're trying to use machine learning to pull that out. And so these red areas are classified as the mining points that have had minerals extracted, and the brown areas are the sort of stockpiles of those minerals. And this goes full circle into enforcement. So we can identify these areas using the model, tell the police about it basically, and they can go in there and steal people's excavators off them, something like that. But it's a nice sort of closed example of actively making things better. So that's it. That's Digital Earth Pacific. Thank you so much for your time. Really appreciate you coming on.